Morning, guys.
Morning. Good morning.
Chris Mullins here again with Mr. Ray Gore, our super tech extraordinaire.
Yeah,
We're very blessed to have Ray. So I could not do my job without Ray. So we're always blessed to have him, and it's always a fun time as we get to do these, right?
yeah, for sure.
We're going to do it when John Jones is out of town.
Oh, that's going to be tough. Because we're going to be fighting, right?
Yeah. So we have to wing it sometimes. John's a natural at it, so we got to kind of work at it, right?
Exactly.
Yeah.
For sure.
Okay.
So it's always fun, though.
It's always fun.
Yeah.
All right, so today we're going to talk about demand testing. We'll talk a little bit. We'll kind of go a little bit into the demand metering side, and then how do we do I should run a demand test. I just want to do a shout out to Virgil Johnson at River Falls. He's one that actually made the suggestion,
Okay.
which is a great one, because I know that some utilities actually do demand testing on top of their registration.
Okay.
So today we're going to do demand testing, and make sure to stick around for next week because we're going to be talking about solar applications on your transformer rated sites. That's going to be an awesome presentation. We got a really good response from last week when we did the self-contained meters. So it's going to be a little more complex with these transfer rated meters. So we're going to talk about again on the utility side applications and see how does that look like when you actually don't run a meter test.
Okay.
All right, let's get into today's agenda.
Alrighty.
We're going to talk about what is demand, what's the point of it, and so as our meter guys know, they get a lot of questions from customers about the charges. So we're going to kind of give a very, very basic way we're going to show how these charges work from the utility's point of view and the consumer. Also, why do we even test the demand? That's a good question, I think, that we need answered. And we're going to actually simulate a demand test and actually run it here on our bench. And then we're going to go into what a register test is, which is a new feature we have in the 3 series that's very unique. And you can only find this in the 3 series. And so we're going to run a test on that, which is kind of similar to demand, but a little bit different. It mostly focuses on energy versus power, which is what demand is supposed to be.
Exactly.
So, but it's a nice little feature. So what is demand? So demand is the total amount of electricity being used by a consumer at any one time. So think of it as the amount of work that's being done in an increment. And so an increment or an interval, it could break down, most of the time, most utilities break it up into a 15-minute interval. So as that utility uses that consumption in that 15-minute interval, they measure that and they can build accordingly, right?
Exactly.
So this is typically expressed as kilowatts, not kilowatt hours, right?
Right.
So we're looking at actual power, the actual summation or the average of the power as opposed to kilowatt hours. Right. Now when we do a meter accuracy test, we're looking at kilowatt hours.
We're looking at kilowatt hours.
Yeah,
exactly.
so that how much kilowatt hours was consumed during that period of time when we tested that meter based on the KH value. Demand, we're looking at average energy being used in that period of time.
Yeah.
So how do the demand charges work? Like I mentioned, most utilities bill on a 15-minute demand. Some bill on 5, some on 30. I've seen some as much as 60. I think those 6 are very unusual, but most people do it on 15-minute. And it's always billed at kW at a different rate.
Yeah.
The kilowatt hours, let me make sure that everybody understands that kilowatt hours and the kilowatts are billed at a totally different rate.
Different rate structures.
kW is always much more expensive, right?
Yeah.
Versus the kWh. So let's go through an example of the charges a customer would have. So let's think about customer number 1 or consumer number 1. They've got a 20 kW load and they consume that for an hour. So that means they used up 20 kilowatt hours.
Okay.
And consequently, that is the same for demand, right? They use 20 kW in that 1 hour period. Makes sense. So 20 kW times 1 hour is 20 kW. So it's pretty easy to figure that demand up, right? So the thing about consumer number 2, who uses 2 kW in 10 hours. 10 times 2, 20 kW. So he's used the exact same amount as consumer number 1, but his demand was only 2 kW during that period of time. So that translates to 20 kW. So they're both the same, 20 kW hours between consumer number 1 and consumer number 2. Now what's important is that the customer used the same amount of energy, but they're billed differently. I mean, why is that?
Well, what's happened here is they've actually, like customer number one, used so much energy in that particular time. So his demand was more, so he needed more to do what he needed to do.
Yeah.
So that's where it is a totally different structure. He's going to be in a totally different rate structure than number two.
Right. So if you look at customer number one's bill, because he used so much energy in that short amount of time,
exactly.
he gets penalized.
Right.
It's almost like a penalty, right? Wouldn't
Yeah.
you say so?
Yeah.
And the reason why the utility does that is they want to offset the cost of the infrastructure needed to be able to supply that kind of demand to the customer.
Exactly.
So the utility, the generation side, is looking for a very smooth demand curve. And if you have a spike demand curve like this, that's going to force the utility to, build another station,
Exactly.
run more line. They don't want to do that because that's going to cost a lot of money. So they're going to offset that painfully in an economic way to the customer to say, you need to figure out, how to decrease your demand.
Exactly.
So, because customer number one, he got nailed with a $101 bill, right? Because he used that high consumption during that period of time.
Exactly.
But number two was smart, and he kind of spread across his consumption across 10 hours. He only owes $11.
Right.
Notice how the differences in the rate, and this was kind of I talked to other customers and like what is their billing demand rate? And this was kind of a swag. So they bill $5 per kW, right? But it's only 5 cents per kilowatt hour.
Yeah.
And that kilowatt hour goes for residential, and this one because it was considered a commercial customer too.
So different rate structures per different usage of customers.
Right.
So, if I had let's say that I have a bunch of inductance motors, so I'm going to possibly be billed off of a power factor penalty as well. So,
True. We don't get into power factor penalties, but that's a great great point. So I kind of polled some of the customers about when do they actually switch over to a customer to a demand customer. This particular customer told me that anybody over 15 kW usage over 2 to 3 consecutive months was considered a demand customer.
Yeah. Yeah.
Or if they're a 3-phase customer with a 50 kVA transformer.
So
And you mentioned that was a pretty big size
that's pretty
customer,
good size,
right?
yeah. 'Cause that's 150 kVA.
Yeah. Per
If
phase.
it's a bank, it's a bank of transformers. So yeah, that's pretty large.
Yeah. So your larger customers are the ones going to be affected by this. And
Exactly.
but if you think about it, the way the utility works, 80% of their revenue is based on these large commercial industrial customers anyway, right?
Right.
And then the 20% is what's left over for your residential. So you're making the money on the kilowatt hours, but you're also making big bucks on the demand charges you got and power factor penalties
Power
if
factor
it
penalties.
applies.
Yes, sir.
So if a customer comes up to you, if you're out there, you're rolling the truck and you're out there testing the meter, and they come out and say, "Hey man, my bill has gone crazy. What can you do?" So this is some tips they can give, and there may be an actual department in your utility that kind of covers this. But if they look at any kind of energy efficiency, that will help, decrease that. That's the expensive route. The more practical route is to offset or stagger your equipment
your
use.
motors, bringing them on.
So you got motor number one running, and then motor number two is off. Switch number one, go back up motor number two. So it kind of staggers that demand. That's why you don't have that big peak like customer number one had, right?
Exactly. Yeah.
Another one is just disable some equipment when not needed. So if you got seasonality, so say for example you're creating widgets in the spring and then widget number two in the fall, instead of run those simultaneously, run that first one, the first run, manufacturing run in the spring, and then switch over to the fall, and that way you're not hitting those peak demands and get penalized for it. So why do we test the demand? For a mechanical meter, a little more complex. Well, actually a little bit more.
Yeah.
Sort of complex. For solid state, from what I've found, it's mostly just a programming error. So they don't have the timing, the billing interval, or the program correctly. So for example, it should be a 15-minute, but it comes up as a 30-minute demand interval. That's a big problem, obviously.
Or they end up programming, let's say you want a 5-minute interval, and you end up programming for 5 minutes, and let's say that you go 2 days, and you may not get all the data that you need out of that program if you're using 5-minute intervals. Your data storage may not be able to hold that much.
Yeah.
So that's another big thing for solid state meters.
For mechanical meters, a little bit more easier to find, right?
Yeah.
Because you can have the timing motor go out, stuck register pins that could affect it. And Ray's going to go over and show us, kind of the details of how the mechanical meter and what kind of failure modes you can see.
Okay, let me get by you here if you don't care. Okay, so I've got an electromechanical meter here. The big thing I want to discuss, though, is if you do any type of demand test on an electromechanical, write down the kilowatt hours that you see here, and then write down the demand before you start doing any type of moving. This little handle here, changing anything. So, and again, remember this little dot here is actually going to be a decimal place. So it's going to be a number, dot, 0, 0, whatever. So real quick though, the things you want to look for in electromechanical is this little reset switch in here has a little nut in there. If you see that, and that little arm sometimes is bent. Sometimes you might have to tighten this up just a little bit, just to make sure that actually the person's actually resetting it a little bit better. The second thing is, here's actually the demand motor that Chris had mentioned. That motor there is the main culprit here that has the issues. So that motor there operates this down here, these little dials here. And of course you can see what I was saying, if you reset this, and of course you see that this dial doesn't go all the way to, it doesn't go to the 0, it's going actually past. So there's a couple of things that that will give you an indication, that's an indicator very quick that you've got some problems. And don't forget your good old potential lights here. See these bulbs here? Sometimes they're out. That's also a good indicator to check your potentials. But anyway, that's basically it on it. And of course, what you can do is if you are going to run a demand test on this, is to line it up and reset that, and then just kind of look at this demand and see if it a little bit matches up what your PowerMaster is showing.
Thanks, Ray.
Okay.
So that kind of breaks down how the mechanical meter
Yes, sir.
failures you can see in the meter itself. In a solid state, like we talked about, it's really just a programming error that we found.
Yeah, yeah.
So again, why test the demand? I mean, like Ray was talking about with that mechanical meter, you can actually put that up and use hook a PowerMaster of it, and you get 100% registration.
Yeah.
But the consumption may not be right.
Right.
If you think about it, and you've got, and we can simulate on this bench. If you have a leg out, right, meter still register 100%.
Yeah, sure will.
But it's two-thirds energy.
Yeah.
Same problem you would have with a demand meter.
Yeah.
So here's kind of a breakdown of the screen. So this when you do on a test on the PowerMaster, it kind of breaks down each interval. Most of the time, there's a 15-minute demand. Most of the time, you have 5-minute intervals. There are some cases where you do 3 minutes. So if you had a 3-minute interval and a 15-minute demand, you would have 5 rows, right?
Yeah, yeah.
This case here is it's a 15-minute demand with 3 5-minute intervals. It kind of
That's
breaks
correct.
down.
Yeah.
And then so you can see the consumption being consumed. This one's actually looking at the energy side. We're going to look at the demand side, which is the KW. But it shows the KW, it shows KVA, and it shows VARs as well. And it also gives you the registration of the meter at the same time.
Okay.
So some of the options you can choose on the PowerMaster, you can choose a period of 5, 10, 15, 30, or even a 60-minute interval. We can display energy or power, which is typically most people are looking for the power.
They want power instead of the
Yep, so you can set up in the preferences about the demand sum, so you can do watt hour over hours, which is sum all intervals. So as it sums all up, all the kilowatt hours consumed, it will give you a summation of it all.
And that's in user preferences,
That's
right?
in user preferences,
Okay.
yes.
Yeah.
Demand average is the average of all intervals, so it would be like if it's 900 watts, it'd give you an average of like 900 or so at the end.
For all 3 phases.
Energy is the summation. It's the average of all intervals as well. So it's
Okay.
the average kilowatt hours seen in that 5-minute, 3-minute, whatever interval you have.
Okay.
So you can choose time interval at 3 or 5 minutes, like I mentioned. It does perform the meter registration at the same time. It also supports end-to-end testing, which is a feature mostly used for our customers in Canada, which they call it synchronization to clock. So you can actually synchronize it to the 5-minute increment on the PowerMaster. So for example, if I started the test at 10:01, it wouldn't start accumulating until 10:05.
10:05, exactly.
And then it goes on to 10:10, 10:15, 10:20, so forth. It's similar to the MV90, the way the MV90 worked. That's how they were trying to match up with the MV90 and its end-to-end testing. They kind of came up with this solution.
Okay.
So now Ray is going to be able to show us how to set up and actually run the demand test on the meter.
Okay, and we're going to use a 3 series here. And so what we're going to do is the first thing we're going to do is we're going to go to meter testing. We've already have chosen a site, if you can see in the upper right hand corner. And then what we're going to do is we're going to do select customer load. And the most important thing is here, guys, when you're doing a demand test, make sure the meter is in test mode. Okay? And then here we're going to go to demand test. So we're actually going to place a check there. And we're going to set it up for a demand period of 15 minutes. And you've got here use internal pulser. If you use the internal pulser, it's just going to pulse, but it's not going to really show you a registration. So, and of course, Chris went over the synchronized test to clock, which we just went over that. And then we're going to hit next. Okay. And then make sure everything's hooked up correctly there. And we're looking for pulses. Now, if we come over to our meter, the most important thing we want to look at here is when I test these type meters, when I'm doing any type of demand test on any meter, what I'm going to do is I'm actually going to just write down the kilowatt hours and the kW. And then once I do that, I'm just going to make sure that they've got me out here testing this meter. Let's just make sure that it's actually, actually consuming. So we're going to hit start test. And again, we're just making sure that the register is doing what it's supposed to do. And here we got a start time. So okay, so we got one pulse at 120 volts and current at 2.45. My power factor is 1, and my watts is 43.
So if the customer didn't want to use pulses at all, what would they do?
They could actually use that internal pulse.
Gotcha.
That I just showed you there. They could use that.
What does the internal pulser do?
The internal pulser is actually, the PowerMaster is actually providing the pulse for you.
Gotcha.
So, and it's actually calculating it off of the voltage and current. And that's when you're getting your registration. So, okay, so it's counting down. Estimate time remaining in the intervals 3 minutes and 54 seconds. So again, if you were wanting to actually, if this was in watt hours, the calculation, of course, will be 120 times your current 120 volts times 2.45 amps times power factor, which will give you your watts. And then if you're doing a 5-minute time interval, you can actually calculate that off of time, which is, I think, 5 minutes is 0.08333, and then multiply by 3, and that'll give you your watt hours. So, but anyway.
Is there anything important that needs to be on the display? Like, for example, I've seen that some meters, they have minimal display on there. So what would you recommend the meter technician to have programmed so they can see it on the display, so they can do a cross-check between the PowerMaster and the meter display?
Some of these meters will now display, it'll give you a what type of service you're using. Some will give you like your kilowatt hours, your kW, the cumulative kW. And the reason why that's so important is because, I'm glad you mentioned that, Chris, I totally forgot about it, is because every time whoever reads that meter, when they go out and I think it's on channel 2 here that I've got the kW on. Mm-hmm. So once that kW is on channel 2, it immediately goes, once it's reset, it immediately goes to the cumulative KW.
Okay.
So you want to make sure that when you do any type of reset, that it's actually adding that to the cumulative KW side, which is, I think that, yeah, cumulative. So see, so if I hit this reset button here, that's going to throw that 9.903 over there on the cumulative side. And so that's another thing that you can always do too. You just press that in and hit reset.
Is that reset button standard on all meters?
Yeah, but some of the meters nowadays, of course, you can read by phone, so you wouldn't probably have to do that. But it's still very important that you actually write down the kilowatt hours and the kW while you're there. Again, which is your energy and power, and just write those down just so you can document it, and that you have that information. So when you go back to the shop, they were like, okay, well, now the meter's not calculating it at all. So what was it when you were there?
Right.
So it helps the back bill.
So is it important to put the meter in test mode before you before you reset the register?
Yes. Well, let me say this: if you are actually, before you do anything to the meter, again, make sure you write down what the reading is on the meter. That's the most important thing, because if you don't, you're going to mess up the whole entire billing structure for that month.
Gotcha.
So what I would do is, if I was going to test the meter, I would definitely put it in test. But if I was going to reset that meter, I always like to do it with it not being in test, so I can actually see that it's actually doing what it's supposed to do.
Okay. So again, if it's not in test mode, it is critical to communicate that as found, as left, KW read before you leave the site.
For sure. Because that could create, especially if it's an MB90 meter, because they actually got to go in there and add the pulses. It's a pain to do, because you'd actually have to go back in there and reprogram the pulses, what it showed before you were there.
Right.
So anyway, okay. So
we probably don't have 15 minutes to sit around and wait, right?
No. So
we did run a demand test earlier. So Ray, can you go back and just show kind of the breakdown of that one? It's in recall data.
Okay, I can go and hit previous here. And then I'm going to go to main menu, which is 7, recall data. What's this thing doing here? I hit too many keys, didn't I? 7. Okay, so this more than likely was under a 9S test. Expand. And today is the 20th. Expand. Okay, we're looking at a customer load test here. All right, now here's your demand results, test results here. So again, what Chris had mentioned a little earlier, you see the watts is now 900. Well, it had summed all 3 phases here. So when they're asking you, want to know what you're looking at, then you can actually go down and explain to them, this is your watts on all 3 phases for each sub interval. So this interval here was a 5-minute interval, that was a 5-minute interval, and that was a 5-minute interval. And so this is your test results within those intervals. You can also look at your VARs here, and then you can also look at the total right here of watts, and then the minimum, and then the max. So all that's good data. And hey, another cool thing is you can actually go over here and toggle back, and there's your meter registration.
Nice.
Yeah, I like that. I like that feature. And you can also get your basic test data too. So you can actually look at your volts all the way across, and then your currents all the way across, and your watts. And you can also look at your frequency and harmonics as well.
So the kind of nice thing about it, it kind of runs 2 tests at the same time, doesn't it?
Yeah.
Well, I guess 3 tests. It actually saves all your basic test data, like your vector, your waveform, harmonics.
Vectors.
It saves your meter registration, and most importantly, it saves the demand test.
Exactly.
Yeah, all in one shot.
Yep. So that's a really cool feature, and I enjoy that. Especially, it's very helpful when you're out in the field, because they could say, hey, did you get a meter test? What does the meter test look like?
Yeah.
So you just go over there and hit your basic test data, and you can get all that as well.
Could I use a demand test if I had a load box? If I had
Yeah.
a 335 or if I had a 7 series?
Yeah, now you can do that. And I've done this a lot of times. Let's say you get out there, they want you to go out and test the demand using a 7 series, and you get out there, there's no load on the meter. So again, the first thing I would do is write down the kilowatt hours and the kW, everything that I'm looking at before I've touched that meter. Then what I would do is I would go into my PowerMaster 7 series, and I would use manual load box control, and I'd run 120 volts at 2.5 amps. And then I would hit previous and go out there and run it as a customer load test.
Yeah.
And then I would test that meter. So once I'm done with that, I would then go back, hit previous, save the data, hit previous, and turn off my manual load box control before I start disconnecting stuff.
Yeah, so the reason why we want to, even though we're a big proponent of customer load testing, I understand if you run a demand test and the test is over, you're going to look up pretty quick to see what the register is so you can compare the difference.
Exactly.
Now, if you had a load box and everything's simulated, it stops, it starts and stops at the exact same time. That way the meter is dead and you can verify that the registration, the kW read is the same as what's on the PowerMaster. So from a demand point of view, I think it's not a bad thing to use a load box test in this case because you can simplify your actual test.
Yeah. And also, it's a good thing too, is let's say you get there and you're looking at the current and it's going up and down, up and down.
Sure.
So if there's no inconsistency in your current, hey, why not run a phantom load on it and get some consistency and go from there.
I think Jared said we got a question.
Virgil says you have to compare the demand reading on the meter to the PowerMaster, correct?
Correct. Yes. So to repeat that question, Virgil asked, we have to compare the register on the meter versus what the PowerMaster is seeing. That is correct.
Yeah, especially on electromechanical too.
Yes.
That way you can kind of figure out, if that little motor's dragging inside, you might have a dial that's touching the base of the meter that's dragging a little bit. So, and that's what I was saying. You can actually just browse over and take a look and see what the demand is doing while you're running the test.
All right. I think that about does it for demand. You want to move on to register?
Yeah, let's do them.
So a register test is somewhat similar to demand test, but it's more looking at the energy consumption as opposed to the power consumed. So what's kind of cool about a register test is you can start that at any point. So the register test allows you to kind of look at the kW read, type that in the PowerMaster, start, and then it runs, and as it consumes, you're trying to compare what the PowerMaster sees and what the meter sees.
Exactly. A lot of register testing will take place with 2S meters. You might have some, and believe it or not, I've actually ran into a meter that was actually tested fine, but the register wasn't accumulating. So there was no energy and it was no power. So, but it tested fine. But
sure.
The good old faithful, when I wrote the kilowatt hours down in the KW, when I was bagging everything up, putting it in the truck, I went, wait a minute, how come, and it's a huge building, I'm like, how come this meter has not moved? I said, that's not possible. So I knew right then that the register was bad.
Right. So the nice thing about this also, you can also apply CT-PT ratios if you have that enabled into the program of the meter as well. And this is unique to only the 3 series. The 7 series doesn't support it, or a 5 series doesn't support it. Only the 3 series.
Only the 3 series.
So right now, Ray is going to... Oh, let me just show you the breakdown of the screen. Sorry.
Oh, yeah. Okay.
So this one actually had the CT-PTs applied. It ran for 30 seconds. And so the actual register is what was consumed in the PowerMaster. That's what the PowerMaster measured. And so at the end of the test, and you'll see this when Ray runs it, you can actually manually type in the register that's on the meter, and then we calculate the % accuracy based on that.
Yeah. Okay.
Right. So Ray's going to show you how to use it now.
Okay. So again, we're back hooked up to the meter here. Okay. And so the test mode is in kilowatt hours. So we're going to do for 30 seconds, and let's actually change this to 60, whatever you want to do. And the CT ratio here, let's say that you have programmed the CT and PT ratio values in the meter. So you would actually indicate that there. So we hit next. Okay. So when I'm actually wanting to start, I can actually look over here at the meter. And just again, I'm just going to make sure, what I normally do is I'll wait and look at the kilowatt hours just to verify everything's moving the way it should. I'm looking at the arrow, it's pointing to the right, so it's giving me an indication that we have the correct flow. And so I'm just going to hit start. Okay, now the thing of it is about this meter is you can see the way this meter is actually programmed. It's programmed, it says just 0 there for kilowatt hours, right? Okay, and then there's your kW at 0.607. And then remember, and that's the cumulative that I have programmed to show. And of course, I forgot to mention that that's the number of resets when I actually hit this reset button here. And that 1.8 right there, I just put that in there, programmed it into the meter just to show that the meter it does have a 1.8 kH value inside the meter. So it's a pretty good little programming thing there. All right, so the actual accumulation right now, and the reason why you may not see any of the numbers on this particular meter is because it's looking at a whole number here, like Chris had mentioned a little earlier.
Yeah, based on how many decimals you have showing on the meter display, you could be out there for a while.
See. Yeah. So in other words, so what he's saying is, I've actually programmed this meter, so I know that that's a 5. In other words, that's a 5 number display there. So it would need to say 0.0000 to actually let you see the actual accumulation from the PowerMaster versus the meter. Okay, so here it says it's done and time remaining is 0, and I ran it for 60 seconds. But of course the meter's not going to accumulate anything because it's a whole number set at 1. So if I would have went in and programmed that meter to give us 0.0000, we would have came up with this 1479. But anyway, so what you would do is you would hit your start, let's see here, let me see if I can back it up. 1 there, which that's what we started with. And then you can say the end register, once it says 0, hit 1 there. Okay, so, but that's what's on the meter now. But again, it's not going to come out right because it's looking for a 1 there. So it's looking for a whole number. So we would have to run it for probably an hour.
Probably about an hour to get that register to, the meter register to actually change. Yeah. So
that's how it works. So again, you can actually use this. Again, it's a programming, so you can actually use this feature, but make sure you match the program up to the feature that you're using. Same with the demand. So let's say, for example, I get out there and I hit this and say, done, and I've got an error, or calculate here. Let's calculate. Let me redo it here. We'll do it for 30 seconds. So anyway, let's say that I've got an error. Well, it's not necessarily an error because the meter's not programmed for a whole number. I mean, it's programmed for a whole number, decimal. And we're looking at, decimal here. Yeah. So it's not necessarily a problem. Yeah. Just like a demand, if I test that meter as the demand, and it's set up for 5-minute demands, and you're asking for 15-minute demands, and you know, if you get some type of inaccuracy, check and see with the programmer how it was programmed. Right. So, but anyway, we're going to put a 1 there.
If the meter technician has a time, it is always good if they can to interrogate the meter to make sure the program is correct. Yeah. We have seen a lot of programming errors, wrong case of H, wrong CT-PT multipliers plugged in, wrong domain interval. So there can be programming errors right off the bat that we found.
So it's a good idea to know that the thing of it is when I went out to test demand meters, I always ask if it was electronic meter, hey, what program is in it? If not, if I didn't know, I'd go out and do a lone diagnostic hookup with a metering software and look in it and see exactly what it's, what is actually measuring.
Yep.
So, but okay, so we're done with this, but let me show you one more thing here. Like we put 1 here and then calculate, and then it says test failed, right? Well, it's not really a failed because of the way the meter's programmed.
So in this case, we probably need to run that test for a lot longer.
A lot longer, exactly.
To get that.
Exactly.
Now, is it easy to reprogram the meter to show decimal points? Or is it just says, no, you got a whole number and that's all you got?
Well, I mean, you can do that, but again, you got to think about if it's a large usage of kilowatt hours, then you're cutting yourself, you're shorting yourself. So if it's
becomes a number that's really, really big.
Exactly.
Right,
then no, you want to leave it as is.
Gotcha.
You're just going to have to sit there and wait.
Gotcha.
But if it's a point to where they don't consume that much, then you can program the meters like that. But normally, a lot of people just program it to five whole numbers on the kilowatt hours.
Mm-hmm.
So
Now, but I believe, and correct me if I'm wrong, if you do a demand test, you don't have to do a register test, and vice versa. It's telling you pretty much the same thing, because
Yeah.
it's looking at consumption of
Yeah.
either power, energy, demand, power,
Yeah.
register test, energy. A meter test may be able to give you the same answer in a shorter period of time. At least you can verify the meter registration is accurate. And then
Exactly.
you do the demand test, 15, 30 minutes, whatever your interval is based on.
yeah, but again, I mean, this does it both. I mean, I've got if you ask me, did you test the meter? I can provide you with the meter testing results, and I can provide you with the demand testing results.
Gotcha.
All in one shot. So,
That's true. That's true.
So I
guess if you wanted to do all,
yeah.
what's the one I can do with the minimum amount of time? That would be a demand test,
Yeah.
right? Because you got all of your basic test data,
exactly.
you got your meter test result, and you got your domain consumption all in one test.
All in one test.
Yeah.
So yeah, if you ask
15-minute
that, yeah.
test.
So
Does the 7 Series support register tests?
The question was, does the 7 Series support register testing? The answer is no. This is just a 3 Series feature.
yeah.
Now, the 7 Series does support demand testing.
Yeah.
So the 3 and 7 support both demand,
same.
but the 3 Series only supports register testing.
And the 4 Series does the demand test as well.
4 Series as well,
Yeah,
okay.
you have to do a little different. You have to actually reset the meter on the 4 Series. And then once you reset it, and then you hit start at the same time, you press them both at the same time, and then it accumulates, and then you write down the ending number.
So for those who don't know, the 4 Series is our, it's got a ZIF socket where you can plug the meter in and just actually run a phantom load test only. There's no
Yep.
CTs, no
No.
connections, right?
But that thing, it's good too. So you get the same thing with it is what you're seeing here.
Gotcha.
So
Okay. Don't forget the promo.
oh yeah, when does that end? The 31st,
End of this,
right?
end of this
October
month.
31st?
End of this month. Yep.
And that ground lead comes with it too, right?
ground lead comes
Which is-
with
okay.
it. So the nice thing about this bench, you can test CTs, you can test a meter. It's a great little, really economical bench that the guys can use in their stand, in their meter shop.
Doesn't it have some resistor of some sort?
Oh yes,
over to
good
the
point.
right?
So so if you have a 3 Series and you ever want to check out the burden measure,
Exactly.
it has a built-in resistor on C phase where you can actually simulate resistance, so you can see how that burden measure goes in and out.
Okay.
Yeah, good
So
point.
that's cool.
Yep.
I actually hooked up a KYZ on mine.
Yep, it supports KYZ too.
Yeah. So
All right, tune in next week. We're going to talk about solar applications on transfer rated meters. Should be a good one. Again, we got real good response on the self-contained, so I think we're going to have a good response on the transfer rated as well. So I think that kind of wraps it up, guys.
all right, heck yeah.
Want to thank Ray for joining me. Want to thank Jared again
Yeah,
for
thanks.
always being there.
Thank
and
you.
Thanks everybody for tuning in and watching us. And check us out next week.
Everybody stay prayed up.
See you then.
See ya.